Okay, this is problem 1 of tutorial 2. And it's a simple truss problem. Well, not so simple. This is probably your first example of an indeterminate structure. But in this case, it's actually pretty straightforward to solve. To those of you who are trying to find out how to figure out the indeterminate forces, the reaction forces, I'll let you know now that I'm not going to tell you the exact location of how to get the reactions. I will tell you that it's probably easiest if you use method of sections. But I'm not going to tell you exactly where to make that cut because I feel like that is very important for you to be able to develop on your own, because I'm not going to be able to tell you where that is on an exam. That in mind, I'm just going to cover some very basic stuff about method of sections and method of joints in here, and I'll tell you, I'll show you that it's not too difficult to get the reaction forces. So yeah, let's talk about reactions first, because that everyone's probably most familiar with those. Let's look at a truss that's like this and like this. It's not perfect, but you guys get the picture. This is 10. This is 20. I sometimes drop my units, but don't drop your units. It's really bad. And you have 4 at 4, 2 at 3. Okay. So for the global system, these are pins. For the global system, you have 3 equations that you can use, just like you can use for any other problem. You can use sum of fx, sum of fy, and sum of m about a point. In our case, you can very easily get the reaction, the vertical reaction at A or J by using moments, and you can get the other reaction by using Fy. So let's do that quickly. 10 times 6 plus, this is moment about A, with clockwise being positive, plus 20, 20 times 12 equals Jy times 16. Professor uses Vj here. You know, it's the vertical direction and the point at that section. I just use the joint label and then use subscripts to label the direction. You can use whichever one is more convenient for you. Just label it clearly. From here, you'll get Jy equals 18.75. From sum of forces in the y, you get Ay plus Jy equals 0, and Ay has to equal 1.25, sorry, equals 20. Okay, now the reason why you cannot get the reaction forces just by using, you cannot get the x direction forces by using m and fx. You were able to get it in this case, but you'll find very quickly that you will not be able to do that in the other case, and I'll just show you an example of why that's not, why that's the case. Let's look at f of x. That is ax plus jx plus 10 equals 0. Now let's take the sum. Let's take the moment about any point. You can literally do this about any point, B, C, D, E, F, G, H, any point that's off the truss altogether as well, and you should get the same scenario. Note that you can't take the moment about A or J, because then you won't have your fulcrum about AX will be 0. For our purposes, let's look at point D. You should notice very quickly, if we go this way positive, that 20 times 8 equals ax times 6 plus jx times 6. I don't know if you can see this right how many of you saw this right away, but note that these two, they're not linearly independent. What do I mean by that? If I rewrite this, do you see how you cannot have ax plus jx equals -10 and ax plus jx equals 160 over 6? This cannot be done. You do not get two values. You just can't solve this equation. That would yeah, I don't know how to say that any more ways, but this equation, this gives you results that mean nothing, because there is no combination where you get ax plus jx equals two different numbers. But that is okay, because you can actually, I won't tell you exactly where to make the cut. You can make the cut anyway. Oh yeah, I forgot to say, I got markers. So I got the same color as the professor, although I don't think I'll be able to use nearly, I don't think I'll be able to use the colors nearly as effectively as he does, but I'll try. You have to make a cut somewhere. You have to use method of sections. You could try using method of joints, but I will warn you now, the method of joints will take you a very, very long time to get the reactions. And you'll because it's such a complicated and tedious way to get the reactions that way, you'll probably make a lot of mistakes and just get the answer wrong. So I would definitely use method of sections. Now you have to be very careful with where you make your section. You can make your section here. You could make your section here. Here also works. Notice that there is some degree of symmetry. Yeah, basically when you do method of sections, in this case, you want to try, because method of sections you normally use when you're only interested in finding one or two forces. You don't want to, method of joints usually requires to solve many, many member forces. Let's say I start here, then I have to find here, 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 here. Like you have to work your way all the way around. In our case, we are interested in finding all the member forces, so using method of joints is not a bad idea. But usually you want to try using method of sections. And when you're using method of sections, you usually want to try and make the cuts as few as possible. That way it's much easier to work with. You want to try cutting as few sections as possible. So here we cut 2 sections. Here we cut 4 sections. And I think that's about the only way. You could try making a cut, say, here. And a corresponding cut over here. And then there's a few other things. Like you could try cutting here. Let me use a different color. You could try cutting. See, like you do not, this is red, you do not want to use this kind of cut. You do not want to make this kind of cut. Your cut, I am pretty sure, I'm nearly positive that your cut has to be linear. And you do not want to try cutting across this because you have forces everywhere. Anyway, those are, the green ones are basically like potential cuts. One of them, or 2 of them rather, I should say, are very good choices. But I'm not going to tell you which one of those are. You'll have to figure that on your own, and it'll be good practice because something like this will probably be, it may be an exam question. So yes, let's look over method of joints very quickly. Method of joints. Remember, you start off at a single point. Let's say we're looking at G. I always say that my members are in tension. That way, that if I get a negative, because I say that they're always in tension, every negative sign I ever see means it's in compression. So this is FGJ, FGH, FGF. This is FGE. For method of joints, you have 2 equations, f of x and f of y. This is joints. If we were trying to draw f of x, I'll note here, we have a very nice thing like this. So this means that whenever we're interested in a vertical component, we'll multiply by 3/5. If we're interested in a horizontal, we multiply by 4/5. And where does this come into play? For example, we're interested in, let's do f of x first. Here we are interested in the horizontal components of all our members. So we'll say, FGE times 4/5 equals FGH, which is horizontal, so we don't need to modify it, plus FGJ 4/5. And that is our f of x equation. Our f of y equation is FGE times 3/5 plus FGF equals FGJ 3/5. That is your method of joints. And you do this for every single joint. So normally if you have, you can get 2 equations from this, so you usually only want to work with joints that have 2 unknowns. So for example, normally if you wanted to use method of joints, you would have to find the reactions first, and then work from there. You have to work from somewhere where you only have 2 unknowns. And for example, in our case, if we start off at point J, if we know the reactions at J, we know the X component and the Y component, then GJ and HJ are 2 unknowns, and we have 2 equations, so we can solve that. Solve method of sections. Method of sections is interesting because it's general. It's just a lot faster. Let's do the hypothetical case where we cut through the bottom half. Let's cut through here. If we do that, then our forces are going to look something like so the AX and the reaction forces get kind of messed up in this case. They look very weird, but AY, because they're all overlapping. But this is your section. And note that you also have, when you do method of sections, you're really getting 2 sections. This is section 1, which is the bottom half. The top half is up here. So notice that I reversed the notation. My first letter always represents the point that I'm coming from, and the second letter is the point that I'm heading towards. So FHJ equals FJH. They're equals. It's not negative, it's not inverse, it's not anything else. They're equal to each other. And yes, when you're using method of sections, you get 2 equations. you have three equations: f of x, f of y, and a moment about a point. And then this is when you have it like this. This is very similar to problems that we've been working with in the past. I'm not going to go into detail about showing you a calculation like this, but yes, it's those are the two different types of sections, and you can cut a section arbitrarily. Just remember that you want to try and cut as few members as possible generally when you're doing method of sections. Normally, let's say if you were interested in, say, force CE, in that case you would only want to cut like here, because you want to, if you're just interested in this force, there's no need to cut all the forces, to cut all the members. You cut the member that you're interested in. Yes, sorry, this video is a little long again. I'm going to try working on cutting down the length, but this indeterminate, this is probably your first example of indeterminate problem, and I just want to make sure that you're able to understand that it's just because it's indeterminate does not mean that it's unsolvable. You just need to use method of sections or method of joints to get the extra force that is currently unknown. Sorry, that's here. Anyway, let us know if you have any questions.